Hello everyone, I'm Yu-Hsin from National Taiwan University. Today, I'm going to present HapticSeer. Haptic feedback could significantly enhance gaming experience, which is a popular virtual activity. There are so many games in the world. According to a well-known review aggregator, Metacritic, there are more than 70,000 commercial games around the world. Moreover, there are more than 500 games scored above 90. That is to say, there are tons of high-quality content with great potentials for Haptic developers to use. However, adding haptics to a commercial game usually requires having access to modify its codebase. This limitation makes it challenging to add haptics to commercial games, which are typically closed source. One workaround that Haptic developers have used is the in-game audio analysis based on the audio features such as volume and impulses. For instance, HapticVec, a controller presented in Ki-19, adjusts its operating frequency by the volume of the rainfall sound playing in the background to create a haptic ring. However, this audio-only approach is limited in precision and limited in the types of events it can support. Therefore, we present HapticSeer, a multi-channel, black box, platform-agnostic approach to detecting game events for real-time haptic feedback. Our system is motivated by two key insights. On the one hand, all games produce three types of data streams: video, audio, and control I/O, which can be analyzed to detect game events. On the other hand, according to our survey of top FPS and racing games, most games with the same genre use a small number of user interface design patterns so that code written to detect events for a game can be reused for many other games. To be more specific, Haptic developers need to replace an unsuitable component only with one tailored for the target game. They don't need to swap all components in this scenario. We developed an open source framework to capture video, audio, and control I/O in real time. It provides the capture data, event system, and abstraction for feature effectors and event detectors to simplify Haptic devices integration. To validate the system correctness and performance, we implemented several real-time multi-channel event detectors for commercial PC and VR driving and first-person shooter games. For example, we use a pulse extractor alone to verify that HapticSeer could achieve 100% accuracy in predictable conditions, showing that the audio approach is reliable. Moreover, we evaluated the system in natural settings for reaching a better understanding of HapticSeer's capability while being used as a developer tool. For instance, we launched an OCR number extractor and XBox controller input capturer to support an inertia detector and a speed detector for famous racing simulator, Project Cars 2. Then compare the output with ground truth extracted from the game's telemetry tool. Furthermore, to collect feedback from Haptic developers, we invited several developers to integrate their Haptic devices with commercial games using HapticSeer. Developers reported that HapticSeer could make the integration of Haptic devices and commercial games easier. We discussed some future work in the paper. For example, users reported that it will be easier to assemble components if HapticSeer has a graphical user interface. Furthermore, we plan to build a toolkit to help users create and share their components at ease, since the power of an open platform will prevail after building a solid user base. In conclusion, we have shown the feasibility of extracting game events from commercial games to integrate Haptic devices by developing an open source framework, making it easier for Haptic designers to support games even without access to source code of a specific API. With HapticSeer's modular and flexible design, we hope that it could form an open source community and enable swift integration of Haptic developers' works into more commercial games. Thanks to my co-author and collaborators for all the hard work on this project. Please find more details for both implementation and usage instruction in our paper, and check the source code published on GitHub. Thank you very much.